Hello and welcome everyone to the class. So I'm Zia and we are going to start with organic chemistry. So before starting with organic chemistry, if you want to know more about me and why am I teaching organic to you guys, you can check out my about me section or I'll even post out a video about it, okay? So yeah, feel free. You can be assured while learning from me that you'll get to the utmost potential of organic chemistry. So I will teach you few things and basically a lot of things that you would not study anywhere in this world. Maybe that's an exaggeration actually, but yeah, I can assure you that I'll teach you a lot of amazing things up to the level of advanced where you won't find it in a lot of coaching materials too. So yeah, let's get started with it. So basically I've decided to divide the course into three sections. So as you know, organic chemistry is a vast part of our chemistry, and it's basically in your 11th class, and then you will see it again in 12th. So basically, if you have heard about organic chemistry in your 10th class, then you must have heard that carbon containing compounds is the basic constituent, like particle this carbon is, of whole organic. So in 11th, what you will be discussing is general organic chemistry. This is the heart of chemistry. If you understand general organic chemistry, then you have completed almost all the concepts. Although a lot of teachers don't teach every concept, but I'm going to cover all the concepts of organic, complete organic. And you can actually, I'm going to teach after general organic chemistry reaction mechanisms, which is an advanced topic, but if you learn this really well, then you will be able to work with any of the equations that we are going to come across. Okay, and 11th basically considered of your general organic chemistry, basics of it, not level up. And then the your second part is your alkene, alkanes and alkynes. Okay, these videos what I'm creating will be on specific topics because I cannot create very in detail videos. So we'll be looking at concepts and questions across them. There might not be as much as definition that you required for your board exams, so you should check out the definition yourself too, but I can assure you that your concept will be really good after this course. Okay, so in 12th class it basically goes around those functional groups that we are going to study. Functional groups like carboxylic acid, ketone, aldehyde, and a lot more we are going to talk about. Those are the functional groups that we are going to start in your 12th class. It starts with haloalkane and then goes on. Okay, we'll discuss about them when we are there. Okay, so we'll start with general organic chemistry in this video. General organic chemistry. So what you need to know about general organic chemistry. First and foremost, if you are new to organic chemistry, I want to recommend you that just work hard with general organic chemistry. It can make your whole chemistry so easy and you'll find it much more fun because a lot of people might tell you that it's all about mugging up, but no, it's not. You'll find the concepts in this general organic chemistry. Okay, so general organic chemistry, we are going to start with uh, firstly, there are a few concepts that you must know, okay, before starting general organic chemistry. So yeah, the first concept is resonance. So then firstly, we are going to talk about functional groups actually. What are functional groups? And I'll give you a short trick to remember their names in the order of their priority, okay? So there are basically, how many are there? I'll give you a short trick to remember it, okay? So you can remember this: acid, let me just derive, poisonousness, Okay, carbonyl reduced to alcohol. So just remember this statement, and I'm going to discuss about it more. So yeah, well, in acid there will be two compounds. In your derived there will be four, which are basically acid derivatives. That is why we are putting them as acid derived. Okay, there will be two poisons, two carbonyl compounds, and one alcohol. Okay, and this is their priority. If in a chain you have to name one of them, you have to check their priority and give the main chain to the one who is more prior. Okay, so in acid there are basically two acids. First one is carboxylic. I'm going to write it down as per their priorities. And second one is sulfonic acid. Okay, let's write down their formula. So you can remember carboxylic acid as C double bond OH, and this is one bond. This will connect to your chain. Okay, whatever alkane, alkene, or alkyne, or whatever group it want to be. Okay, and second one is sulfonic acid. You can also write this as RCOOH. Okay, and sulfonic acid you write it as SO3H. Okay, and at the same time, if you want the figure of it, yeah, go with that. Hope you understood it. So sulfur can form total of 6 bonds, so as you can see it here, right? So these are sulfonic acid. Then after acid, what we talked about is acid derivatives, right? So let's go with acid derivatives. So there are 4 acid derivatives, as I told you already. Okay, first one is ester, second one is anhydride, third one is your amide group, and your fourth group is acid halide. Okay, I hope you remember the order in which we are talking. So what ester look like? It's COOR. Okay, or you can write COR. Okay, one of these. Anhydride is basically C double bond O C double bond O. This group is known as anhydride group. Amide group contains acid derivatives with NH2. Okay, and there can be 2 or 3 types of amide. We're going to talk about all of that. Acetylide is basically COX. Okay, we are done with acid derivatives. Next one comes is our poison. As I already told you, right? 2 poisons. Cyanide, you must have heard about it. Cyanide and isocyanide. Formulas, let's go. C triple bond N and N triple bond C. Okay, hope you understood it. So these are the two. So main bonding with your chain is carbon here, and here in isocyanide it's nitrogen. Okay, and after that what comes is your alcohol, right? Oh, did I miss something? No, yeah, I did miss. After that comes is our, I'll provide you the sheet. Okay, that is why I'm writing down and not rubbing things. After that, what comes is known as your carbonyl compounds. Okay, there are 2 carbonyl compounds that you must know. First one is your aldehyde, and second is your ketone. Okay, aldehyde and ketone. Okay, let's write down their functional group. C double bond O. This is ketone. and this is your aldehyde, C double bond OH. Okay, so here a H is there, but here ketone will always be present in the bit in between. Okay, so there both sides it will have some carbon chains, whereas aldehyde have one side hydrogen, so it can only link from one place. Okay, next is your alcohol, simple OH alcohol, as I talked about. Then you can also see amine group, which is your NH2 group. Okay, now what I wanted to talk about in this video, the main topic that we are going to cover is our resonance. Okay, the concept of resonance, why it comes. Actually, I have my notes around with me, so I can help you out with some definitions which are important. Okay, not all. So we are going to start resonance. Remember, a lot of people get confused in this concept, but it is so simple, and I'll make it simple for you guys, and I can assure you, you're going to learn something amazing. Okay, so basically the resonance, why the concept of resonance came. So the issue was that a single compound structure was not able to explain all property of the compound. So as you can see, if you have this compound, then what happens is, like, if we see generally by normal sense, then you can see this charge is right here. This bond length should be as a single bond, right? And this bond should be of length of double bond. But what happens is, due to resonance, what happens is, like, if I want to create this resonating structure, what happens is, like, this negative charge comes here and this goes there. As you can see, now it becomes CH2 CH double bond CH2. You can also write it as CH2, then this CH2 and dotted on both sides. So this electron, actually what it gets is, it is delocalized. So this is not localized electron, it is delocalized electron. Okay, so yeah, if that's the case, then the bond length will be different from our original. So that created a lot of confusion. That's when the concept of resonance came around, and also there were a lot of difference in their properties. So let's write down the definition if you want to write it down. Yeah, listen to me. The process of delocalization of pi electron, lone pair electron / negative charge in parallel p orbitals is called resonance. I'll repeat again. The process of delocalization of pi electron / lone pair electron / negative charge in parallel p orbitals is called resonance. Okay, so for resonance, the system should be conjugated. So another condition is conjugated system. Conjugated system, what does we mean by conjugated system? All of the things must lie in same plane, which means there should not be sp3 hybridized atom, because sp3 hybridized one bond will be in another plane. So three continuous atom should be sp2 / sp hybridized, one of these. If they are either sp2 or sp hybridized, then your resonance will take place. Okay, otherwise it won't, because for resonance, as I told you in the definition, so electron displays in parallel p orbitals, but when it's not planar, one p orbital will be in different plane and electron cannot displace in that. So yeah, here is where we are going to talk about resonance, and I'll make it more easier for you guys. I'll give you 6 conditions and you'll only find resonance in those conditions. A lot of teachers don't teach this, but yeah, let's get started. So the first condition is CH2 double bond CH single bond CH2 with positive charge. In this case, resonance will take place. Its resonating structure is main resonance hybrid structure. If we draw that dot 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 CH single line again like that whole time, and we can give a partial charge on this. So this positive charge is not completely on this CH2 but partially on both of the CH2. And if somebody asks you to draw its resonating structure, so you can draw its resonating structure. This is the last time I'm going to draw it. I hope you can draw it yourself next. Okay, or you can also keep it like and plus half and plus half on the other both side. Okay, so this is first condition. The second condition is your CH2 double bond CH single bond CH2 negative charge. Okay, so remember, for resonance, write down a note. Starts making notes. For resonance, electron, what happens is electron goes from electron source to electron sink. I'll explain you what it means by, and even in definition we talked about it. Pi electron to cation, or a lone pair electron goes into a vacant orbital. Okay, a negative charge goes to electronegative element. Okay, so yeah, and these alternating these structures are known as resonating structures. Okay, or you can also call it canonical structures. Hope you're getting it till now. So yeah, and this structure, the final structure, is also known as resonance, is known as actually hybrid structure. Resonance hybrid structure. I hope you understood it. So yeah, second condition, you draw it. Okay, you can draw it for yourself. I'm sure you can. I believe in you. Let's go to the third condition. Our third condition is similar. So what happens is, like as we have talked about here, that electron goes from the source to the sink. So pi electron goes to a cation or a similar way. Okay, so the third condition is your CH2 double bond CH single bond CH2 lone pair. You can see this in the case of amines too, that in nitrogen have lone pair, right? And it is NH2, so this lone pair can travel actually, and same way you can make the structure of it, right? So it will become a negative charge or lone pair right here. Negative charge is usually said to be as like a lone pair, so you don't need to differ between them. Okay, the third condition is done. You do it. Okay, you can do it yourself. The next condition is your conjugation of pi bond with pi bond and odd electron. Okay, odd electron is basically this A double bond B, and C have only one electron, not two electrons, such as CH2 double bond CH single bond CH2. So I'm going to help you out with this resonating structures. So how to draw this resonating structure of this one is, you need to make an arrow but a half arrow. Okay, and then you need to put two electrons here, right? There two in this bond, half arrow from here and half arrow from here, and you can draw the resonating structure as CH2 CH double bond CH2. Hope you got it. The fifth case is conjugation of pi bond with another pi, so we also call it pi sigma pi. Okay, how it works is A double bond B C double bond D. pi sigma pi. Okay, so let's create a resonating structure for this. So what will happen here? Let's draw CH2, double bond CH, single bond CH, double bond CH2. So what will happen here is these electrons will travel out there and these will go there. So let's create this resonating structure. As now this carbon has one less bond, so it will be like this, and it will be CH double bond CH and CH2 negative. You got it? Easy, right? The sixth is the most important condition. Okay, a lot of people don't know about it, but yeah, this condition is really important and you should remember it. The first five conditions were really easy, but the sixth condition is the one that you need to focus on. The sixth condition. So in sixth condition, when it's also called as back bonding, we have learned about, you must have learned about it in P block, or yeah, P block, I'm sure. So compound, where you can write about it, a compound in which one bonded atom is electron deficient. So one bonded atom should be electron deficient, and another adjacent bonded atom is electron rich. Shows your resonance through back bonding. Okay, such as BF3. What happens is, like, as you already know, this has 6 electrons, lone pair. It goes to B and it creates a structure like this. Or you can also see CF3. So its resonating structure will look like something like this. Easy peasy, right? And how it happens. So what are the conditions for back bonding? So the first condition for back bonding is one of atoms should have extra electrons, right? I'll explain it a bit more in the next video. Maybe it should have extra, which means lone pair or negative charge or something like that. Then second condition is the other electron should have vacant orbital, which is basically vacant p or vacant d orbital. How to know that it has vacant p orbital? So easy. So for p block, it has vacant orbital if its octet is not complete. Octet incomplete. Okay. Then it has vacant p orbital. Okay. But for but for D block, it will have D block usually have vacant orbitals. Okay. Because it can expand its octet. Okay, I'll show you. So if any atom belongs to third period or next, they will surely have vacant D. They will surely have vacant D. So but for second period elements, you have to check whether they have vacant P or not. Easy trick to check, as we already did in CF3. The carbon has 2 less electrons for octet. And firstly check, is there any third period or onward atom? No, there aren't. Fluorine is in second period, this is in second period. So it can only be possible by second period if it has an incomplete octet. I'll give you another example. This is really important example, okay, and a really good question. So in this case, tell me whether resonance is possible or not. Resonance. Let's see. Carbon has 8 electron, no vacant p. And so you might think that although it has lone pair extra electrons but no vacant p, So you might think that no resonance, right? But that's wrong, because we have talked about it already, that this is chlorine. It is from period 3, and for period 3 and onwards they have vacant D. So what will happen here is this negative charge will go there, and the resonating structure would be this way. Remember this a lot of people will give you wrong answer for this question. Okay, so this is the resonating structure for that. I hope you understood it. The video got quite long. Yeah, I'll provide you this slide, overall slide that we studied on in the resource panel or anywhere for sure. And about that, so what we learned today, let me summarize. And this was just a intro sort of video, so that is why it took a long, and we did not talk about a lot of concepts actually. In the next video, we are going to talk about some advanced resonance feature, where we'll be seeing some advanced questions from JEE Mains and even JEE Advanced and some of the previous year questions, along from the NEET part 2. Okay, so we are going to talk about advanced resonance, where so that will be an optional video. If you want to learn about resonance, this much is enough, more than enough. But if you want to compare that which of these compound, which one of the resonating structure is better, or which one of these compound has more resonating structure and it's more stable, then all of these things we are going to cover in the next video. So it will be really amazing. But yeah, that is an optional, because that's in an extra. Okay, if you don't learn it, then it's okay. And after that, we are going to get into aromaticity and then start with basic inductive effect and all of those effects, which a lot of students get confused on. So hope you understood all of this. From today, we talked about resonance, we talked about different functional groups, and we talked about the 6 types of resonance and how resonance is possible in each possible way. I'll see you in the next one, where we are going to discuss about some extended conjugation, cross conjugation, and a lot more things, where we are going to check stability of resonating structure and a lot more. I'll see you in the next one. See ya.